Okay, so some things that we need to remember. Parts of a circle. Of course, this is called what? A radius. What's this called? A chord. If that chord goes through the center of the circle, it's called a diameter. If the chord continues on and goes through the circle, it's called a there it is. If it just touches the circle, it's a tangent. And of course, there will be a relationship between that tangent and the radius. It will always be perpendicular, 90 degrees. Well, there's another thing that relates to all this. I know it's not far off from that brown diameter, but this green diameter is perfectly horizontal. And that horizontal diameter is called a reference diameter, or the main diameter of a circle. Off of that reference diameter, every point on the circle has a value. For example, this point right here. If I measure the distance of that point to the reference diameter. Now, distance is always measured at a right angle, at a perpendicular. So the distance from that point to the reference diameter would be that right there. Well, this point also has a distance right there, correct? This point would have a distance right there. Every point has a distance. That distance for a given point is called that point's sine. Make sense?
Sine is the distance.
Is the distance from a point on the circle to a reference diameter. So why am I discussing all this? Well, because we're going to start talking about trig, and you'll look at here, you'll see the word sine, tangent, secant. Those are actually our three main trig functions. Everybody thinks trig came from a triangle. Trig has been applied to a triangle, but trig, all those trig functions actually came from a circle. It's something called a unit circle. A unit circle is a circle with a radius of 1. One unit, period. Yeah. Whatever units you're going to use. Exactly. 1 unit. On that unit circle, we have our reference diameter. How long is that reference diameter? 2 units. Very good. What would the circumference of this circle be? 2 pi. You got it. Now we've discussed this a little bit, and I'm going to put this in here just to as a reference, this line right here. We discussed a little bit that this is 0 degrees, 90 degrees, 180, and 270, correct? Remember that discussion briefly? 270. Yep. But anyway, if we have an angle, let's just pick whatever angle we want here. Let's call this 35 degrees here. 35 degrees. That angle intersects the unit circle at this point. So the properties of that angle, sine, cosine, sine, tangent, secant, are defined through that point, not necessarily the angle itself. First of all, how far is it from the center of the circle to that point? 1, because it's a radius, right? How far is it from the center of the circle to here? 1, because it's a radius. Very good. Now this also is going to define something called radians. We haven't talked about those yet, but we're going to talk about them a lot. Radians are another way of measuring angles. The length of this arc here on the unit circle is the measurement of this angle here in radians. So radians are a measure of arc length, but they also measure angles. For example, 35 degrees, well, that's going to be the circumference is 2 pi times 35 over 360. So 2 times 3.14 times 35 divided by 360. That's 0.6106 radians would be that angle in radians. So the length of that arc on the unit circle is that angle in radians. Next we have the distance from this point down to that reference diameter. What is that? That's the sine. Remember? Distance from a point on the circle to the reference diameter. So the sine of the angle, in this case the sine of 35 degrees, is just that length from that point down to the reference diameter. That one's pretty straightforward. The next two are kind of dependent on each other. Tangents are always measured from the reference diameter. Tangent at the reference diameter. So it's either going to tangent here or over here. Well, over here, this would never intersect it. So our tangent we're going to be concerned with is right here. I can keep going or whatever, but I'm going to stop there because that's where I'm going to want to stop anyway. Secants are measured along the reference diameter is called the initial side of an angle. This dark blue line here would be called the terminal side. That's where the angle stops. If it starts here and rotates that way, that's where it ends. That's where it terminates. So the secant is measured along that reference or that terminal side of the angle, and it continues through the circle. The secant continues through the circle instead of stopping at the circle like a chord or a radius. And it goes until it intersects that tangent. So the length of this line here, which is the tangent, is the tangent of that angle. The length of this here is the secant of that angle. And those are our three main trig functions right there on the unit circle. What do we note about the secant? Can I have a secant of 0.9? No, why not? Yeah, the secant will always go outside the circle. The radius is 1, so the secant has to be bigger than 1, always. So the secant always greater than 1.
That cosine on your thing?
No, we haven't got to cosine yet. The three main trig functions are actually sine, secant, and tangent. Cosine gets used a lot, and I'll show you how that comes in a little bit. So secant's always bigger than 1. What do we know about the sine? Well, the sine, as the angle gets bigger, the sine gets larger until we get up to here, doesn't it? Smaller than or equal to 1. Sine can equal 1 at 90 degrees. It's exactly 1 there. Then it starts to get smaller again. And then here it actually gets negative until it hits -1, and then it gets larger until it's back to 0. Right here, of course, at 0 degrees, the sine is 0. It gets larger until you get up to 90 degrees where it's 1, and then it gets smaller until you get to 180 degrees where it's 0 again, and so on. Tangent well, at 0 degrees, the tangent would be 0, wouldn't it? But it keeps getting bigger and bigger and bigger. At 90 degrees, how big would it be? Well, there wouldn't be a tangent at 90 degrees, would there? because at 90 degrees it never comes. But let's say 89.9 degrees. This is going to keep shooting up and up and up and way on up out here, right? It's nearly infinitely long. So tangent can be anything. We put it from negative infinity to positive infinity. Because, of course, if it were down here, it could go down to negative infinity in length. So the tangent really has no limits on it. Does that make sense? So a secant's always bigger than 1, sine's always less than 1, and a tangent can be pretty much anything. So you might be wondering, well, we didn't really learn a lot about secants, we learned cosine. Where's all this come into play? So there's my reference diameter. And I'm going to draw in this vertical line here just for reference. Now we see it spelled without the hyphen in it now, but it really is hyphen. Co stands for complement. Cosine of 35 degrees is really asking me for the sine of, what's the complement of 35? 55 degrees. Where did I get 55 from? 90 minus 35. Cosine is asking for the sine of the complement. So if I come back up here, this is 35 degrees. Where would its complement be on this graph? Right here. Right? That's 55. Right. So its sine, all would have when I'm using the cosine, all I really have to do is change my reference diameter. Instead of using this horizontal diameter, as my reference diameter, I'm going to use this as my reference diameter now. Because I want the complementary angle. And the complementary angle goes up to the horizontal instead of to the vertical instead of the horizontal. This is the complement of that. Always, no matter what this angle is, this angle will be its complement because it's 90 degrees. So the cosine is the sine of the complement, or this length right here. That's the cosine. Does that make sense?
What about if the angle is 100?
100 degrees, the cosine would be right here. Goes to the vertical. Now then, of course, the cotangent would come from here, and the cosecant would go out here. So in this case, you can see the cosecant would be bigger than the secant, because the secant's going to stop in here somewhere. But that's not always true. As we get further up here, the cosecant gets small and the secant gets larger. But you can see these are all now horizontally oriented instead of vertically oriented. The way we typically do this is when we look at an angle, this is its sine right here. And then since that forms a rectangle, this length is the same as this length. So there we call that the cosine. But all of this, all the stuff that we've applied to right triangles comes from a circle.
So at 45, the cosine and sine are the same?
Sine and cosine are the same. Secant and cosecant are the same. Tangent and cotangent would be the same at 45 degrees. And over the next couple of classes, we're going to look at a whole bunch of relationships between these angles. And we're going to see how they relate to a right triangle. But for now, that's just your introduction. Something to get you thinking about. Trig is not what you thought it was. It's used for what you learned, but that's not where it came from.